the population growth in the lovely Costa Rica.
Here we have our data table. In the leftmost column, we have our years listed from 1950 to 2010, the years in which we collected data from. In the center column, we have our X values ranging from 0 to 60. X is the number of years since 1950, so 0 would be 1950 and 60 would be 2010. In the rightmost column, we have our Y values, which are the total population. In 1950, it was 959, but these populations are represented in thousands, so it would actually be 959,000. Not only did we put the data into Excel, but we also put it into our calculators. To do this, we click Stat, Edit. In the left column, you put your X values ranging from 0 to 60, and in the right column, you put your Y values that coordinate with your Once X values. Once the data has been put into the calculator, you are going to find the model for the exponential regression. In order to do this, click Stat, scroll over to Calc, and scroll down till you see exponential regression. Then click Enter. Where it says Store, click Alpha F4 and press Enter so that it's entered into the Y1s in your Y equals. Then click Calculate. In the calculator, the exponential regression is written as Y equals A times B raised to the X. Using our data, our exponential regression would be Y equals 1,037.977,656 times 1.026715364 raised to the X. In order to find the growth rate of our exponential function, we know that Y equals A times 1 plus R raised to the X is the same as Y equals A times B to the X. Both of these are ways to write an exponential function. Therefore, our B value is equivalent to 1 plus R. In order to find R, which is our growth rate, we subtract 1 from 1.026715364, our B value. Here we find that R is 0.026715364. In order to find the growth rate as a percentage, we multiply this number by 100. Here we find that the growth rate of our exponential regression is 2.67%. Using the calculator, we can also find the model of our logistic function using our data. In order to do this, you would click Stat, Calc, and scroll down to Logistic. Then you click Alpha F4 and put in Y2 since your Y1 has already been used for your exponential function. Then press Calculate. The standard form for a logistic function is Y equals C divided by 1 plus A times E raised to the negative bx. Using our data, our logistic function would be Y equals 7,486.749438 divided by 1 plus 6.8853577797e raised to the negative 0.0398295816x. To find the growth rate of our logistic function, we find the absolute value of our B value, which is negative 0.03982958816. So the absolute value of that would be 0.03982951886. Then you multiply this value by 100 to find the growth rate percentage. This means that our growth rate of our logistic function is 3.98%. Now that both the exponential and logistic functions have been calculated and stored, we just have one more thing to do. Press second Y equals and make sure that your first stat plot is on and that it is a scatter plot. From there you may press graph. Here you will see your exponential regression, your logistic regression, and the points from your data table show up. From the looks of our graph, The logistic curve seems to fit our data the best. To predict the population in 2020, you first have to know that 2020 is 70 years from 1950. From there, you can go to your table and scroll to the X value that reads as 70. Here you will find that the Y value reads as 5258.6. When you multiply this by 1,000, you would find that the population in 2020 would be approximately 5,258,600 people. To find when the initial population in Costa Rica would double, you would multiply your initial value, which was 959,000, by 2 to find that when the population doubles, there would be 1,918,000 people in Costa Rica. Once you have completed this step, go back to your table. Find the value closest to 1,918, which is also known as 1,918,000, but since we are on a scale, it's 1,918. These values should be in the logistic curve model. You will find that the 1,918 will occur between the 21st and 22nd year after 1950. Because the 22nd year after 1950 has a greater population than 1,918, you know that 1,918 would occur in the 21st year, meaning that the Costa Rican population would double in the year 1971. Some indicators of the growth of the population in Costa Rica are the production and consumption of electricity and improved sanitation facilities. Production and consumption of electricity are indicators of an economy's size and development. As economies on modern sectors grow, such as industry, motorized transport, and urban areas, energy's usage grows. The electric power consumption, kWh per capita, is 1,957.2. Electric power consumption measures the production of power plants and combined heat and power plants less transmission, distribution, and transformation losses and own use by heat and power plants. In the years from 2010 to 2012, the United Nations says that 220 million people gained electricity. Areas that were prioritized because of their potential for commercial development was high. Both Thailand and Costa Rica were rural regions that were electrified quickly. As of 2015, 94.5% of the Costa Rican population has had access to improved sanitation facilities. This means that a vast majority of the people in Costa Rica use facilities that separate human excreta from human contact. The sanitation reduces the odds that one will contract a disease and spread it around to others. In the 1980s, urbanization in Costa Rica was popular. Migrations of massive amounts of people from other Central American countries fled to Costa Rica. This led to the increase in the prevalence of malaria and other diseases. However, in 1990, 88.4% of the population had access to sanitation facilities, which means in the 1980s, about 85 or 86% of the population in Costa Rica had access to sanitation facilities. Since sanitation facilities help to reduce the amount of disease that is spread, the Costa Rican population slowed in growth rate, but the population continued to increase because more people were continuing to flee their country, and some died, but outbreaks were not as widespread because of the number of people with access to sanitation facilities was so large. Thank you for watching. This production was brought to you by Cameron Jones and Catherine Tallman.